Hello, everyone. Today we're going to do Introduction to Python Part 2. So by now, you should hopefully have written a few programs and had a bit of trial and error and discovered the joy of bugs and debugging. So to start off this lecture, we're going to talk a little bit about debugging because this is a very important skill and you'll be doing this throughout your whole CS career. If you become a TA, you'll help other people debug their code as well. So, as I'm sure you've probably already experienced, errors may often occur when programming. And this is perfectly fine, by the way. This happens to everybody. This happens to professionals. That's why we test often. The idea is not to be perfect on your first run. The idea is to test often and to debug. So the process of tracking down and fixing errors or bugs in code is called debugging. So this will be harder to enforce remotely, but this is how you want to be writing your code. So you code and you test in small pieces. So what you don't want to do is write a 25-line program, then test the whole thing. Nope, nope, nope. You want to write 2 to 3 lines, then run your code and see if it works. If there's a bug, fix it, and then write 2 to 3 more lines, then test all of them, and so forth. So if you don't do this and you have a 25-line piece of code and then you come to myself or the TAs, we're just going to have you comment out or delete out the majority of the lines and start from the beginning. And it's really kind of a waste of your time as well, because you often have to restart from scratch and do things differently. So it's best to get into good habits now from the beginning. So we're going to have you do this. So if you wait until all your code is written to test, the following things can happen. Your program will fail in obscure, hard to diagnose ways. You will spend a lot of time looking for bugs. Some bugs will actually stay hidden for a long time, which is actually more dangerous. And you may blame Python, the class, the professor, the TAs, everyone else except maybe yourself for the error. So let's get down to details about the different kinds of coding errors that can happen. So syntax errors, let me talk about these first and then I'll come back to the other ones a bit more. So let me go to this slide. So syntax errors, they're very, very common. So each programming language, like each natural language, has its own rules. So just like we have our own rules in English, like we have rules about commas and apostrophes and capitalization, each programming language has its own rules and keywords and operators called syntax. So when learning a programming language, you must learn the syntax rules. Now, when we speak using natural languages like English, humans often violate the syntax rules, but we can still understand them mostly. But with a programming language, if you violate even one syntax rule, this will cause the Python interpreter to just stop executing the program, and you will need to fix it. So if we go back to this slide with this syntax error where we say name equals, in fact, let's do this. So let's go ahead and pull up our terminal. And let's go into interactive Python mode. And let's literally do what's happening here. So we say name equals input. I think it just says, yeah, enter your name. And you can see we have an error here. Actually, it's giving us an end of line error, but it is because of a syntax error, because if we finished the quotation mark, then it would be able to run. and you can just finish it off like that. I'm actually going to go into a lot more detail about other kinds of errors, but just to give you a couple more examples. So runtime errors. So this is, for example, there's different types. Like you could get a zero division error if you're trying to divide by 0 here. And then you could have a logic or semantic error where the syntax is perfect, but there's something wrong with the logic in your code. So your code might run fine, but the output is not correct. So we're going to come back to those as well. So I actually want to go over some different kinds of errors. I think that this, How to Think Like a Computer Scientist, has a great page on section 3.4 that I'd like to go through some of them with you, but you should definitely go through these on your own as well. So there's a link here, but it's also part of your homework to read chapter 3, and particularly please look at this page. So one of the really nice things about How to Think Like a Computer Scientist, that you can run code and do things interactively on their website. So I'll just make it a bit bigger. So for example, it says here, many problems in your program will lead to an error message. And then the person who wrote this says, for example, as I was writing and testing this chapter of the book, I wrote the following version of the example program. Can you see what is wrong just by looking at the code? Maybe, maybe not. Our brain tends to see what we think is there. So sometimes it is very hard to find the problem just by looking at the code, especially when it is our own code and we are sure that we have done everything right. So let's have a look at this code for a second. So it's asking for input. So what is the current time in hours? And it's asking for how many hours do we want to wait as input. And then it's converting these to ints, and then it's adding them together and then printing the final time. Now, by all means, please pause the video and see if you can figure out what's wrong. But what we can also do, which is really nice, is we can run the code here. So we could enter something like 3 and then 2, and then it will show you that there's an error. So it's saying there's a name error. Wait time int, the variable, is not defined on line 5. So here is line 5 here. So it's saying wait time int is not defined. So let's have a look at what it's saying in the description. A name error almost always means that you have used a variable before it has a value. Now, this is very common with students. I see it all the time, so it's a good one to learn. Often, it can be a simple typo, or they just haven't initialized the variable yet. So to fix, check the right-hand side of assignment statements in your function calls. This is most likely the place where a name error can be found. So if we go back up here, the right-hand side, we have wait time int, the variable. So can you see a place where wait time int has been initialized before line 5? And so the answer is that it hasn't been initialized before line 5. So if you look at line 4, for example, it's trying to convert current time string to an int, and it's using current time string to convert it. Whereas wait time int, it's not using wait time string, it's using wait time int, and it's saying, but wait, we don't have a value for wait time int to convert to an int. So what we have to do here to fix this is we're going to make this a string so that we're now passing in this value, and then we run it. So we say 2, 3, or whatever you want, and now it runs and it gives us an output. So that was the bug on that. And I encourage you to take your time to read through these, in your own time and learn a bit more. I'll just do 1 or 2 more examples. This is a good one, a pass error. So pass errors happen when you make an error in the syntax of your program. So syntax errors are like making grammatical errors in writing. So if you don't use periods and commas in your writing, then you're making it hard for other readers to figure out what you are trying to say. Similarly, Python has certain grammatical rules that must be followed. So I'll let you read this part on your own. Now this one's a bit annoying because you know, we can't make it wider. So you just have to look at the whole thing like this. But there is something to find and fix in this code. So if you can't see it, that's fine. Let's run it and see what the error message says. So it says syntax error, bad input on line 4. Now, I wanted to go through this one because this is such a classic example of something that students hit against, and I think it's quite frustrating for them. So they're looking at line 4, and they're saying, okay, is the variable okay? Is there a syntax error? They can't find any problem with line 4, right? And then, so this is the point where you usually call over the TA, and that's great. We can come and the instructor, and we can come over and help you, no problem. But something that you could do, for example, which they suggest here, well, let me read the description first. This message indicates that Python can't figure out the syntax of a particular statement. Some examples assigning to a literal or a function call. I don't think that's very helpful, but I think they give you a really helpful, like, find includes, like, how can you help yourself to find out this bug? They say one trick that can be very valuable in this situation is simply to start by commenting out the line number that is flagged as having the error. So let's do that together. So let's go to line 4 and comment it out with the hashtag. And let's run it again. Okay, now at this point, the student will get really confused because now it's saying there's bad input on line 5. So now we're looking at line 5. Is there something wrong? Like, this name is correct, the syntax is correct, what is going on? Right. And as they say below, it says, okay, now it changes to point to line 5. Am I really that bad that I have 2 lines in a row that have errors on them? And then they go, maybe. So maybe you could. But if you took it to the extreme, you could comment out all the remaining lines in the program, and now you would get an end of file error. And it's its way of saying that Python got to the end of the file while it was still looking for something. What is it looking for? Maybe it's in the line above. Can you see if there's something missing in the line above? Yeah, there is a parenthesis missing in line 2. So now we've put that back in. Let's uncomment this out. Let's run. And that was it. It was just a missing parenthesis. And it's the sort of thing that can drive students a bit crazy because the error messages aren't simply very helpful there. Okay. Let's have a look at this one. This is a really interesting one, the type error. Okay. So type errors occur when you try to combine 2 objects that are not compatible. So this is why I was really stressing about data types earlier. So for example, you try to add together an integer and a string. Usually type errors can be isolated to lines that are using mathematical operators, and usually the line number given by the error message is an accurate indication of the line. So here's an example of a type error created by a Polish learner. So it's why it's in Polish. So it says, see if you can find and fix the error. Now, I actually don't know what it's asking for here, so we're just going to, but I'm assuming that it's looking for some integers because it's trying to convert these values into ints, and then it's trying to do some kind of division, a modulo operation, and then print, and then add some stuff together, and then print the final value. So if we were to run this, let's say 2 and 3, we get an error, type error, unsupported operand types on line 5. There's a string and an int on line 5. Now, yes, there is for sure a type error here, but there's a reason for a type error happening here, and that error has started before line 5. So while it may look like x has been converted to an int, has it really? So one of the things that it suggests doing, and I think this is a great idea, is printing out values. And let's also print out the type of the values. So we're going to print out the type of x and a, and it might surprise you. So 2 and 3. And here you can see we still got the error, but the important thing is let's look at the types. It's being said that x and a are type strings. So they're not integers, which is what they were trying to do. They were trying to convert them to integers. So no wonder it's having problems doing this division of a string by an integer, you know. And if we fix that, if we took this line out, it would still have problems with this line, and it would still have problems with this line. So this is something that I see students doing a lot, is they convert, but they don't assign. So what we would need to do in a case like this is to say x equals int x and a equals int a. And then if we were to run, it runs, and you can see here it's running as an int, and we no longer get those type errors. Okay, so that's an important one to watch out for. So I definitely recommend that you go through this page carefully and that you do all these exercises. Okay, so let's continue back on the slides. So we went through this. So just going back to syntax errors. So once all syntax errors have been corrected, the program can be compiled and translated into a machine language program or executed by an interpreter depending on the language being used. So fine, in order to overcome avoid syntax errors, become familiar with the Python keyword. So this is in table 1.2 in your textbook, and become familiar with the general syntax rules. So some of these words we'll be learning shortly, but you just want to become familiar and not use them in other situations like variable names. Now, we were talking about logic errors. So once your program can run, it may still contain a logic error. So we were saying, for example, this example is an example of a logic error. So a logic error is a mistake that does not prevent the program from running, but causes it to produce an incorrect result. And oftentimes mathematical mistakes can be the cause. So in order to overcome or avoid logic errors, it is important to understand the task that the program is trying to perform, to think through the logic, and determine the steps that must be taken. So this leads us really nicely into the idea of an algorithm. So this will lead you to develop an algorithm. An algorithm is a set of well-defined logical steps that must be taken to perform a task. So there's a famous example of what not to do with the shampoo algorithm. So I don't know if it's still on shampoo bottles these days, but if you looked on shampoo bottles at the instructions, it would say, okay, shampoo, lather, rinse, repeat. So if you really were to follow this algorithm, you would be washing your hair forever and in an endless loop, lather, rinse, repeating. So you need to be really specific and logical when carrying out and writing your algorithms. And I just want to say that, you know, this is such a great exercise in thinking. I think in the very first class I played that lecture, and there was a quote from Steve Jobs, and he said, everyone in this country should learn how to program because it teaches you to think. And, you know, really, we as human beings, we like to think we're logical beings, but we're actually not. And you get to see that every time when you run a program and it doesn't make sense to the computer and it's just doing exactly what you're telling it to do, and you have to go and find the error in your logic. It's a really good way of teaching you how to think. So let's start with a really simple algorithm here. So say a programmer breaks down the task that a program must perform by creating an algorithm that lists all of the logical steps that must be taken. So say we wanted to write a program to calculate and display the gross pay for an hourly paid employee. So we get the number of hours they worked, we get, you know, how much they get paid per hour, we multiply the number of hours by their pay rate, and we display the result. It's not very hard. So input is number of hours, their pay rate, the process is the multiplication, and the output is the gross pay, which we can use the print function for. So we're going to start with some really, really simple algorithms for you. And in order to do them, you just need to know some simple things in Python. So for example, you want to know how to add and subtract. So we've already done some additions. So, you know, you can use the plus sign. You could use your, 2 plus 3. If you wanted to subtract 3 minus 2, you can use subtraction operand. If you want to multiply, we looked at that, asterisk. We haven't looked at divide and integer divide, so we'll look at that in a moment, and modulo, as well as the power exponent. So let's look at division and integer division. So regular division results in decimal fractions. So for example, if we said 12, and please do these with me in real time, and you can always pause if you need to. So if we said 12 divided by 4, you can see that it gives you these decimals, or these floats. But then if we did integer division with 2 divide signs, you can see that it truncates the answer. So it's no longer a float, it's an integer, hence it being called integer division. The modulo operation gives you the remainder, and this is a really important one. So please learn this one, and if this is tricky, then please come talk to us about it. So the remainder operator literally gives you the remainder, like what's left after division is performed. So we use the percentage sign for this. So for example, if we did 16 modulo 5, the remainder from that is 1, because there's 3 5s, 15, and then if we go up to 16, there's 1 remaining. If we say 10 modulo 4, the remainder is 2, because 2 4s are 8, and if we go up to 10, we have 2 remaining. So like I say, if you're not sure, and for those of you who are interested, if you want that, I put in a link here. Absolutely not recommended unless you really, really want to read it, about Python modulo and floating point numbers. But please ignore that if you're not interested. Okay. Operator precedence. So it's just like math. If you have parentheses, we do the innermost expressions first. Oh, something to remember just for you mathematicians. So when we're doing the power, if we say 2 to the power 3, this is how we do it. We don't say to caret 3, which is how some of you might have been used to doing it. So it's 2 asterisk signs next to each other. So we do parenthesis innermost first, so exponent power, then multiply, divide, remainder. They're all on the same level, and then addition and subtraction. So this is just like math. And if the precedence is equal, you go left to right, same as math. It's just good to know what happens if you have mixed data types like ints and floats. So if you have 2 ints, the value is an int, except like we saw with regular division. If you have 2 floats, the result is a float. If we have an int and a float, the int gets temporarily converted to a float, and the result is a float. And as we've seen in the past, converting a float to an int truncates the fractional part. As we move forward, we'll be making greater use of comments. So comments are just explanatory notes. They're ignored by the Python interpreter, and they're just intended for the person reading the code. So you start with a hashtag. You can do it before, like here, ask user for bank balance, and then you put in your line of code, or you can put it at the end of a line, get velocity from user. And comments are really, really helpful for other people and even yourself, because you may have forgotten why you wrote that piece of code, which I can certainly attest to. But, when you graduate, you'll be working in teams, and a big part of your job is reading other people's code, and other people will have to read your code, and having comments will make you much liked and having nice, clear code. Okay. Now there's these next couple of slides, there's just some things for you to remember, particularly around controlling your output in Python. So when I've been printing, you've probably noticed that I've been using, you can use either your one quotation mark, or you could use, double. If you were trying to quote something like the phrase cura personalis is Latin for care of the whole person, which is a USF motto. By the way, I'm going to copy this. If you want to paste it, you have to do Control-Shift-V or whatever the Mac equivalent of that is. You'll notice if you do this that your quotation marks are not copied correctly, so you have to actually go over them and correct them. Otherwise, it won't run. So if you're ever trying to copy code from the slide, just be warned, you'll have to fix your quotation marks. So for example, what we did here is we put the single ones on the outside, and then when we were trying to do, actually, hold on, there's something quite right. Let's do it like this. And like this. Now hopefully you'll get a quote in the printout. Let's see. There we go. That's better. So, so we have the single ones on the outside. This is just to denote that it is a string. And then if we actually want to use quotation marks within the string, then you want to do something other than what you used on the outside. If you had used double on the outside, you'd want to use the single ones on the inside. Okay. This is very important. I want you to be very familiar that there are multiple ways of printing. So let's do what we were, let me make this a bit narrower, doing before, where we were saying like first name equals, you can put in your own first name or whatever you want. Second name, Lovelace. So then if I were to say print first name, comma, second name, parenthesis, you can see I get this automatic space between the two words, right? But there's other ways of printing things. Like instead of doing that, I could put a plus sign, and then there's no space between them if I put the plus sign. Or if I wanted to put a comma in between them, I could put, and this is in the slide, you know, a string with a comma in it, and then I have a comma in between. So that's what's going on here. And I said try this without the, and that's what I did here. So I just want you to know that there's these different ways of using print. And these I'm going to go through, but you know, obviously please learn these in your own time. This is an important one too. So this stops the print from adding a new line. So we say end empty string, and you can see here there's no new line where the prompt is after the word. You can also fill the end something else like an asterisk, and then it will end it with an asterisk and there won't be a new line. So we will be using that in the class as well. And then let's also look at how to specify a number to 2 decimal places or another number of decimal places. So for example, let's set a variable to something with many decimal numbers. Shouldn't have a space, sorry. There. So let's just check. Total is some number with a lot of decimal places. But say we want to specify that to 2 decimal places, we could say print, and then this is nice, it just says like total price, and I'm going to put a space before putting the quotation mark there to leave in a space. And then what we're looking at here is this keyword format. So we're saying format, and then the variable name, comma, and then apostrophe or quotation mark point, and then however many decimal places, in this case we want to, and F is just stands for floating point number. We're closing 2 parentheses here, and then you can see that it prints it to 2 decimal places there. So format, that's something you definitely want to learn, and we're going to be using that straight away. And then finally, this is also, these ones are important, but the item separator is very important. But let's go through these first. So new line is for sure important. So let's go through that. Make this, okay. So \n advances the output to the next line. So it's like a new line. So for example, if we say print hi, and then we say \n by, you see how it creates a new line between hi and by. We have something with \t, which is similar but with tabs. So we can say Monday, if we would say, this is very helpful if we're making a table, like Monday, Tuesday, \t, Wednesday. And it puts in a tab space between each one. These are pretty straightforward. I mean, if you wanted to print a single quote, this is how you would do it. So we could say backslash single quote, that will give you a single quote. If you wanted to do a double quote, you could do a double quote or another backslash like that. And then finally, we have our item separators. So this is very important. So for example, if I were to print 1, 2, 3, as we know, this will give us a space between each one because we have a comma. Now, what if I didn't want a space in between each one, or I wanted something else in between each one? This is where I can start to use my separator command. So for example, I could put in an empty string with no spaces, and that would take away the spaces. I could put in an asterisk, that would put in an asterisk. You know, I could put in 2 spaces, that would give me 2 spaces. So I can really control here how I want to separate each item in my print. And it will work with print, not say with input or something like that. So F strings and formatting output. So you've just seen these ways of formatting output, but we're going to be using F strings a lot. So first of all, what is an F string? Well, let's start off with what is a string. So a string is a data type enclosed in quotation marks. Be there. For example, hello world, when we had our quotation marks around that, that was a string. So an F string is a special type of string with the prefix F here. So for example, F hello world. And you might be like, well, why would we need that? And because we're going to, it gives us a lot of flexibility with the print function. So let's have a look at some examples. So let's first of all look at F strings and placeholders. So in order to do this, let's go to the Python shell. So if you open up your terminal and then type in Python 3, enter. And here we can just enter like Python really quickly and just go into interactive mode. So say, for example, you create a variable called name, and let's put in Ada Lovelace. So, and you can check that if you type name and enter, you'll see there's your variable name, Ada Lovelace. And then if we do print parenthesis F, so we're going to do our F string, and then we'll do our quotation mark, hello, let's do a capital H, hello, space, and then we're going to do our curly brace and put in the name of our variable, period, close your quotation mark, close your parenthesis. And there you have a placeholder here for your variable, so it will print hello, Ada Lovelace. And then we can also look at this here with variables and expressions. So we can also, for example, do something like this. So we say x equals 5. Let's just check x. There it is, has the value 5. And then we can say print, there's our f, quotation mark, subtract 2 from x. And now we're going to put in our placeholder x, and we're going to put in an expression minus 2. Close our quotation marks, close our parenthesis, and there we get subtract 2 from x, 3. And the value of x, by the way, has not changed. So let's just check that there. X still has the value 5. So we didn't change the value of x. We just printed it and added an expression to subtract 2 from x there. Okay. F strings and formatting decimal places is very important. You'll often be asked to format your output, for example, in class 2. So for example, this is the format specifier for 2 decimal places. F stands for a floating point number. So you can add a colon after the variable and then enter your format specifier. So here this is saying 0.2, so that's 2 decimal places. If it was 3 decimal places, you could say 0.3, for example. So let's try this example. So we say total equals 20 divided by 3. And then let's have a look at the result of that. And you can see that's obviously not 2 decimal places. So let's trim that down in our print. So we can say print F, there's our F string, quotation mark, the total is, and then we put in our placeholder, there's our variable, and then we put in the colon, and then 0.2F. Close your curly braces, close your quotation mark, close your parenthesis, and there it is to 2 decimal places. The total is 6.67. Oh, I'll add that to the slide so you'll be able to see the output there. And then the other thing is you can also add a $sign in front of that. So I'm going to press the up arrow. You can do the same. This will just give you the last thing you typed out. If you press it again, it'll give you the one before. If you press the down arrow, it'll come back. So it's a nice shortcut if you ever need it. And I'm just going to go here, add a $sign. You'll be able to see there's now it looks like we have a dollar amount to 2 decimal places. So that's something you'll be needing to do as well. F strings and percentages. This is also an important one. So let's have a look. So the colon and then the percentage symbol will format a float into a percentage. So for example, if we have discount equals 0.5, and then we're going to do our print with our F string, so F quotation mark, and then we have curly braces, and then our placeholder for our variable name discount, colon, percentage. When we close all of those, and you can see it says 50.0000%. But we can always add our however many decimal places you want. And here, if we don't want any decimal places, so I'm going to press my up arrow and I go back here, and before the percentage sign, I can add, so instead of saying 0.2, we can say 0.0 now. We want 0 decimal places, and then you'll get your full 50%. And then let's just have a look at formatting floats versus integers. So far we've been using the F type designator, in all of these examples. If we go up here, here we do the 2 decimal places up here. But let's try with D, or capital D, which stands for decimal, but which basically is working with integers or whole numbers. So for example, say we have our integer n, and it has a value 123,456, like this. And let's check our value n. And if we just wanted to print that, we could just say, oh, is our f string, we're going to print this. Oh, I need to change this to n here. And here, okay, now that should be better. And so we're going to have our colon and then our D instead of, this stands for decimal. And then we're going to close everything. And there's our regular number. Now, just as an aside, if you wanted to add a comma separator here, you could go ahead and add a comma before your decimal to show, oh, I'd like to have a comma separator just to make it easier to read. So you can print it out like that. But the main thing I wanted to show the difference is, say we had a different, so this time we're going to call it number. Say we had a number like 1, 2, 3, 4, 5, 6, 7.123. And let's just check our number value there. If we wanted to add a comma separator and put this to 2 decimal places, then we can do that with the following. And here we will need the F, this F, not this F, this F here to denote that it is a float type designator. Anyway, so let's do this here. So print, so we're going to do our F string, have a quotation mark, curly braces for our variable number. There's our colon. There's our comma to denote that we want a comma separator in there. There's our 0.2f to denote that we want it to 2 decimal places. Then we close that and close everything else. And there you'll see we get our floating point number with 2 comma separators because it's big enough, and also to 2 decimal places.